which of the following statements is or are true with regard to the device shown here. So the first approach is to determine what device is shown. In this case, it's a hub. So we know already we are looking at a hub device. Now, looking back, we know a hub is a device at layer 1 which does not break a collision domain or a broadcast domain. So this leaves us one option, one collision domain and one broadcast domain. The device shown is a hub, and the hubs place all ports in the same broadcast domain and the same collision domain. With respect to the OSI model, which one of the following is the correct statement about protocol data units? During the lectures, we said, as data is encoded with control information at each layer of the OSI model, the data is named with a short protocol data unit. At the transport layer, the PDU is called a segment. At the network layer, it is called a packet. At the data link layer, it is called a frame. And at the physical layer, it is called bits. So, with respect to the OSI model, which of the following is a correct statement about PPDUs? Except a segment contains IP addresses. We know IP addresses are limited to layer 3, and a segment is the PDU at layer 4, the transport layer. A packet contains IP addresses. This looks good. A segment does not contain MAC addresses. MAC addresses are limited to layer 2. A packet at layer 3 does not deal with the MAC address. So the best answer here to me seems to be B. The contents of a protocol data unit depend on the PDU because they are created in a specific order and their contents are based on that order. A packet will contain IP addresses but not MAC addresses because MAC addresses are not present until the PDU becomes a frame at the data link layer. You are the Cisco administrator of your company. A new branch office is opening and you are selecting the necessary hardware to support the network. There will be 2 groups of computers, each organized by department. The sales group computers will be assigned by IP addresses ranging from 192.168.1.2 to 192.168.1.50. The accounting group will be assigned IP addresses ranging from 10.0.0.2 to 10.0.0.50. What type of device should you select to connect the 2 groups of computers so that data communication can occur? Basically, what this question is describing is a separate network. So we have 2 networks, one in the 192.168.1.0 network and another in the 10.0.0 network. To interconnect different networks, you need routers. So this leaves us with option C. You should select a router to connect the 2 groups. When computers are in different subnets, as these 2 groups are, you will require a device that can make decisions based on IP addresses. Routers operate at layer 3 of the OSI model and make data forwarding decisions based on layer 3 networking information, which are IP addresses. They create routing tables that guide them in forwarding traffic out of the proper interface to the proper subnet. The most effective way to mitigate congestion on a LAN would be to upgrade the network cards, change the cabling to Cat 6, replace the hubs with switches, upgrade the CPUs in the routers. Now, most of these options would improve or reduce congestion in the network, but the most effective here, according to what we've read, is to replace the hubs with switches. Replacing the hub with a switch would reduce collisions and retransmissions, which would have the most impact on reducing congestion. In the following work area, match the OSI model to its protocol data unit. Now remember we said at the transport layer, the PDU is called a segment. At the network layer, it is a packet. At the data link layer, it is called a frame. At the physical layer, it is called bits. So in this case, we drag the PDU to its layer. Transport, we deal with segments. Data link, we're dealing with frames. Bits apply to layer 1, that's the physical layer, while packet applies to the network layer. What is the function of the wireless LAN controller? Now, there are various devices you can find in a switch network. A wireless LAN device, these devices connect wireless devices such as computers, printers, and tablets to the network. Since pretty much every device manufactured today has a wireless network interface card, you just need to configure a basic access point to connect to a traditional wired network. Access points or APs. These are devices allowing wireless devices to connect to a wired network and extend a collision domain from their switch and are typically in their own broadcast domain. Wireless LAN controllers, these are devices that network administrators or network operations centers use to manage access points in medium to large or extremely large quantities. The wireless LAN controller automatically handles the configuration of wireless access points and is typically used in very large enterprise systems. Firewalls, these devices are network security systems that monitor and control the incoming and outgoing network traffic based on predetermined security rules. What is the function of the wireless controller? To monitor and control the incoming and outgoing network traffic. That seems to be a firewall. To automatically handle the configuration of wireless access points. This looks good because a wireless LAN controller is used to manage and configure a huge number of access points. To allow wireless devices to connect to a wired network, this would be the wireless LAN device or the wireless LAN network interface card on your device. To connect networks and intelligently choose the best paths between networks. This looks like a router, so I'll stay with B. Wireless LAN controllers are used to manage anywhere from a few access points to thousands. The APs are completely managed from the controller and are considered lightweight or dumb APs as they have no configuration on the access point itself. You need to provide connectivity to 150 client computers that will reside in the same subnetwork. And each client computer must be allocated dedicated bandwidth. Which device should you use to accomplish the task? Now, the device we mentioned that is capable of allocating dedicated bandwidth to each port is a switch. A switch is a device capable of breaking up a collision domain, or better still, reducing the size of a collision domain. Each port on a switch is a separate collision domain. That means it also has dedicated bandwidth. So if you have 24 ports on your switch, you can have up to 24 separate collision domains, and each port could have up to 40 gigs of bandwidth. So the best answer to this question would be a switch. You should use a switch to accomplish the task in this scenario. A switch is used to provide dedicated bandwidth to each node by eliminating the possibility of collisions on the switch port where the node resides. Switches work at layer 2 in the Open Systems Interconnection OSI model and perform the function of separating collision domains. In the following work area, match the OSI model layer definition on the left to its description on the right. Referring back to our tutorial, the transport layer deals with the coordination of the data transfer between end systems and hosts. The protocols at this layer provide end-to-end data transport services and can establish a logical connection between the sending host and the destination host on an internet network. The best known protocol at the transport layer is the transmission control protocol, which is built on top of the internet protocol. So the best definition here for transport would be end-to-end connection. The physical layer does two things. It sends bits and receives bits. It specifies the electrical, mechanical, and functional requirements for activating, maintaining, and deactivating a physical link between end systems. So looking at the definition for physical, this would be conversion to bits. The data link layer provides for the physical transmission of data and handles error notification, network topology, and flow control. At the data link layer, the PDU used is called a frame. So this leaves us with one option, framing. And finally, routing occurs at the network layer, performed by a router. What is a function? What is the function of a firewall? We mentioned earlier that firewalls are devices or network security systems that monitor and control the incoming and outgoing network traffic based on predetermined security rules. So option A says to automatically handle the configuration of wireless access points. I believe this is the function of a wireless or a wireless LAN controller. To allow wireless devices to connect to a wired network, this is the function of a wireless LAN device. To monitor the incoming and outgoing network traffic, this looks like a definition of a firewall. To connect networks and intelligently choose the best paths between networks, this defines a router. Which layer in the OSI reference model is responsible for determining the availability of the receiving program and checking to see whether enough resources exist for that communication? Remember, we said the application layer is the interface between your program running on your PC and the lower OSI layer, enabling you reach the corresponding program on another PC or computing device. The application layer also identifies and confirms the communications partner's availability and verifying the required resources to permit the specified type of communication to take place. So immediately we see that this answer is the application layer. The application layer is responsible for identifying and establishing the availability of the intended communication partner and determining whether sufficient resources for the intended communication exist. Which of the following correctly describe steps in the OSI data encapsulation process? The transport layer divides a data stream into segments and may add reliability and flow control. This seems to be okay, as it defines what happens at the transport layer and the type of protocol data unit, which is called a segment. The data link layer adds physical source and destination addresses and a frame check sequence to the segment. Now, this part of this defines the data link layer, that is the physical source and destination addresses, which are the MAC addresses, but it does not apply to a segment, it applies it to a frame. Packets are created when the network layer encapsulates a frame with source and destination host addresses and protocol related information. Now, packets are created in the network layer, but they encapsulate segments from the transport layer. And the addresses used are not host addresses, they use IP addresses. So this answer is wrong. Packets are created when the network layer adds layer 3 addresses and control information to a segment. That seems good. The presentation layer translates bits into voltages for transmission across the physical link. This is the function of the physical layer. So by elimination, we are left with A and D. The transport layer segments data into smaller pieces for transport. Each segment is assigned a sequence number so that the receiving device can reassemble the data on arrival. The network layer has two key responsibilities. First, this layer controls the logical addressing of devices. Second, the network layer determines the best path to a particular destination network and routes the data appropriately. Which of the following layers of the OSI model was later subdivided into two layers? This is the data link layer. Two sublayers exist in the data link layer: the media access control sublayer and the logical link control sublayer. The MAC or media access control sublayer defines how packets are placed on the media. Contention or the claim for media access is on a first come, first served basis. Physical addressing is defined in this sublayer. The second sublayer, the logical link control sublayer, is responsible for identifying the network layer protocols and then encapsulating them. The IEEE data link layer has two sublayers, the media access control layer and the logical link control layer. What is a function of an access point? To monitor and control the incoming and outgoing network traffic. That's the definition of a firewall, or a function of the firewall. To automatically handle the configuration of wireless access points. That's the function of the wireless LAN controller. To allow wireless devices to connect to a wired network. This is the function of an access point. To connect networks and intelligently choose the best paths between networks is a function of a router at layer 3. What is an example of a device that operates only at the physical layer? We said a hub operates only at the physical layer. A switch operates at the data link layer. A router operates at the network layer. A bridge also operates at the data link layer. Which of the following is not a benefit of using a reference model? It divides the network communication process into smaller and simpler components. This is a benefit of the reference model. It encourages industry standardization. This is another benefit. It enforces consistency across vendors. This was not listed as a benefit because each vendor can create a network device using the OSI reference model, but it's not necessarily consistent in implementation across all other vendors. It allows various types of network hardware and software to communicate. This is another benefit of a reference model. So what is not a benefit? In this case, it will be C. While it is true that the OSI model's primary purpose is to allow different vendors' networks to interpret, there is no requirement that vendors follow the model. Which of the following statements is not true with regard to routers? They broadcast by default. Routers do not broadcast by default. Routers break broadcasts. They can filter the network based on network layer information. That's true. They perform path selection. That's true. They perform packet switching. That is true. Switches break up broadcast domains, or switches break up collision domains. So switches break up collision domains and routers break up broadcast domains. So the best answer here will be C. Switches create separate collision domains within a single broadcast domain. Routers provide a separate broadcast domain for each interface. How many collision domains are present in the following diagram? Let's start with the first segment. A hub simply extends a collision domain. It does not break up collision domains. So from the perspective of the computers, we have two separate collision domains because the bridge creates a separate collision domain on each port. In this case, we have 3 ports connected to the bridge. So in this segment, we have 1, 2, and 3 collision domains. On the bottom segment, we have 3 hubs. Now, remember, as we said, a hub simply extends the collision domain. So in this case, we have 1 collision domain. So altogether, we have 1 plus 3, that's 4 collision domains already. On this segment, every switch port is a separate collision domain. So we have 1, 2, 3, 4, and 5 switch ports. You add 5 collision domains to 4 collision domains, that gives us 9. The all hub network at the bottom is 1 collision domain. The bridge network on top equals 3 collision domains. Add in the switch network of 5 collision domains, 1 for each switch port, and you get a total of 9. Which of the following layers of the OSI model is not involved in defining how applications within the end stations will communicate with each other as well as with others? Now, if you look back at the diagram shown in the lecture about the 7 layers of the OSI model, you will discover the top 3 layers define how applications within the end stations will communicate with each other and with users. The bottom 4 layers define how data is transmitted end to end. So the best answer to this question, which of the following layers of the OSI model is not involved in defining how applications within the end stations will communicate with each other as well as with users, that would be the transport layer. Because the bottom 4 layers define how data is transmitted end to end, while the top 3 layers define how the applications within the end stations will communicate with each other as well as with users. And these 3 top layers are the application, presentation, and session layer, while the transport layer makes up the bottom 4 layers. Finally, which of the following is the only device that operates at all layers of the OSI model? There are certain network devices that operate at all 7 layers of the OSI model. We have what is known as a network management station, web and application servers, gateways, servers, and network host. So practically that leaves us with network host. A switch operates at the data link layer, a router operates at the network layer, while a bridge also operates at the data link layer.